Welcome back to my channel. In this video, we are going to see exercise 3.4 Maths Matrices, chapter 3, class 12. Okay, first four problems we are going to see. So the first problem is given as 1 minus 1, 2, 3. Okay, so for that we have to consider, let's consider this matrix as A, and in order to get the inverse of this matrix using elementary operation, first we have to consider A is equal to IA. Okay, so A is 1 minus 1, 2 and 3, whereas I is identity matrix, which is 1 0 0 1, and this A we have to write as it is. Okay, in order to get the inverse of A, we have to change the A on LHS to identity matrix I. Okay, so in order to change this matrix, first we'll make this element, which is the second row's first element as 0, and next is the first row's second element as 0. Okay, so first let's make this the second row's first element as 0. In order to make this element as 0, we have to consider one expression which makes that term, especially that term, 0. Okay, so first let's consider one expression as R2, that is R2 is the second row's element minus 2 times the R1, 2 times the first row element, which gives R2. Okay, so this applies to the whole 4 elements of R2, that is row 2. Okay, so first let me just consider this element. So I'll just substitute R2 is 2 there and R1 is 1. Okay, so 2 minus 2 is 0. We have attained our intention, that is we want to get this 2, we have to make this 2 as 0. So that is over. The next whatever we get also we have no problem, because our intention was to change that 2 as 0. That's it. Okay, and this expression we have to apply for the whole second row. So next one is 3 minus 2 times minus 1. 3 plus minus 2 into minus 1 is plus, right? So plus 2. 3 plus 2 is 5. And the next one is 0, this row. Okay, 0 minus 2 times 1 is equal to 0. It has gone, so minus 2. Next is 1 minus 2 times 0. 0 into anything is 0, so it is 1. So these whole changes into the first row's element remains as it is, so 1 minus 1. Next is the 2 changes into 0 and 3 is 5 is equal to 1 0 0 into minus 2 and 1 into 1 itself into A. Okay, so we have changed this term as 0. Now we have to change this term as 0. Now we have to consider another expression which makes especially this minus 1 as 0. Okay, so R2 plus 5 R1 gives R1. Okay, so let's see. First for this one, it is R2 is actually 0 plus 5 into R1 is 5. Okay, and the next one is 5 plus 5 into minus 1, which is 5 minus 5 gives 0. Okay, so minus 1 we have changed into 0. Okay, next is this one. It's minus 2 plus 5 into 1. Minus 2 plus 5. 3. Okay, next is 1 plus 5 into 0, which gives 1. Okay, so now this whole matrix changes into 5 0 0 5, which is equal to the first element of this matrix became 3 1 minus 2 1 into A. Okay, so we have changed the diagonals into 0. Okay, and the only one intention is to make this element as 1 and this element as 1. So divide row 1 by 5 and row 2 also by 5. So if we divide row 1 by 5, 5 by 5, 0 by 5, 0 by 5, 5 by 5. The same here. 3 by 5, 1 by 5, minus 2 by 5, 1 by 5, into A. So 5 cancels, which gives 1001. 1001 is equal to 3 by 5, 1 by 5, minus 2 by 5, 1 by 5 into A. Or we can write this whole as 1001, which is equal to, if we take out 1 by 5 common outside, we'll get 3, 1, minus 2, 1 and A. Here we can observe A inverse is actually 1 by 5, 3, 1, minus 2 and 1. Okay, we found out A inverse of first one. The second question, 2, 1, 1 and 1. Okay, so first we'll consider this matrix as A. In order to get the inverse of it, we have to take A is equal to IA, and we have to change the left hand side A as identity matrix. Okay, so 2, 1, 1 is equal to 1001 into A. First we'll make this element as 0. We'll consider an expression which is 2r2 minus r1 gives us row 2. Okay, so let's check whether this helps us to get this element as 0. Okay, so the first r2 is here 1 minus r1 is 2. 2 minus 2 is 0. Yeah, we'll get it. So next one is, so 2 into 1 minus 1. 2 minus 1 is 1. Next 2 into 0 minus 1. 2 into 0 minus 1. So minus 1. 2 zeros is 0. Minus 1 is remaining. So it's minus 1. Next 2 into 1 minus 0. 2 into 1 is 2. So this whole matrix changes into the first rows remains as it is 2, 1, 1, 0 A. Only the second rows changes. Okay, so that is here it is 0, 1, minus 1 and 2. Now our intention is to change this element as 0. Okay, so here we can observe r2 minus r1 only will get as 0. We'll take it as r2 minus r1, which gives r1. Okay, so the first r2 here is 0 minus r1 is 2, which gives minus 2. And the next one is here r2 is 1 minus 1. 1 minus 1 is 0. Next is minus 1 minus 1, which is minus 2. 2 minus 0 is 2. Okay, and these whole matrix changes into minus 2, 0, 0, 1. And here is minus 2, 2, minus 1 and 2. Okay, here we can observe the diagonals we have got as 0, that is 0 and 0. Only one intention is here we have to get 1, and here it's actually already 1. So divide row 1 by minus 2. Okay, so if we divide the row 1 by minus 2, we'll get minus 2 by minus 2, 0 by minus 2. Row 1 is actually in the form, row 2 is actually in the form of identity matrix only. Minus 2 by minus 2, 2 by minus 2, minus 1, 2 into A. Okay, and here minus 2 gets cancelled, which we get 1, 0, 0, 1, which is equal to, here minus 2 get cancelled, will get 1, 2 get cancelled, here get minus 1 and 2. Okay, so this is the A inverse. So A inverse is actually 1 minus 1 and 2.